We've been doing a number of AND gate videos lately, so I'm not going to dwell on it too much. We're going to use the integrated circuit that we've also been using recently, the 74HC08. So it's the 7408. There's 4 AND gates within it. We're only going to use one. But in any case, when the signal is more than half of the supply voltage, approximately, we'll get a high output, it will be a high input, I should say, and you can call that 1 or whatnot. If the signal is less than half of the supply voltage, then it will give us a low input or 0 right there. Pretty straightforward. For the AND gate here, you need 2 high inputs to get a high output, which will be pretty much the power supply voltage. When you have any low inputs, the output will be low, which will be basically the negative rail right there. We're going to use a light dependent resistor to make the circuit more interesting than the recent ones, and one of the inputs will be controlled by how much light is falling on it. If the resistor, or the light dependent resistor or photoresistor some people call it, is to the positive supply, that means a brighter light will have less resistance, it will raise the voltage, and you'll get a high signal if the light is bright enough. If it's dark enough, it will be low. Whereas if the resistor is on the more negative side, the fixed resistor on the more positive, a brighter light is going to reduce the resistance, lower the voltage. So bright light will be low signal, and dark light will be a high signal for this one. So now here we have our circuit. This is the output to that AND gate there. We have an input, and an output right here. So the output is on its own row right now. This input has a jumper that goes to the switch. This switch here connects the top to top at all times, and so we have a 10 kilo ohm resistor here to the negative rail. It's a pull down resistor. Right now it's a low input. If I press the button, then it connects all 4 pins, and we have the positive right there. We'll have a direct connection to the positive rail. It will ignore that resistor as long as I hold the switch. That'll give it a high input. So we've been doing that recently. Now we're going to add our voltage divider to the other input. So we're going to start with the light dependent resistor on the more positive side of the supply. So the input is right there, and I'm going to leave a little spot so make sure that goes to the positive rail, and we're going to get our resistor here. So it's a voltage divider. The voltage will be anywhere from the positive rail to the negative rail, depending on how much resistance is on either side right there. And we have an LED down here. Of course, the short lead, the cathode, goes to the negative rail. Long lead, the anode, goes up 1 row, and we're going to protect it from 5 volts with a 220 ohm resistor. So the output is the bottom pin right there, and again, this is the 7408, specifically the 74HC08, if you want to look up the particulars. So 220 ohm there, that's a 10 kilo ohm resistor, that's a 10 kilo ohm resistor. And we're all done. So right now the light is fairly bright, especially if I point to it, and if I press the button, now the LED turns on. So we have a high input there, we add a high input, so both of them are high, all of them are high since an AND gate, and the LED is on. If I turn this light on, the overhead light, which is an energy saving light, not very bright at all, there you can see now it is too dark for the LED to turn on. So now, using the light dependent resistor, we can set it up with another option where bright light gives a low input, and that's really easy. We will just swap these two. So make sure we stay to that output, go to the negative rail, and that's really common with these integrated circuits. It's easy to plug it into the wrong pin, and that's how I think I fried a couple. I accidentally powered pins that shouldn't have been powered, and in any case, there we have it wired up. Now the light dependent resistors towards the more negative side. Right there we have the bright light. If I press the button, nothing happens. If I turn the light off and then press the button, so giving a high signal to one input, now we have a high signal to the other. Because this is very little resistance, compared to the light dependent resistor right there as a voltage divider. So this is my quick video series, so I'm going to end it there. And make sure you check out one of the other videos. Click like, subscribe, the bell, and all that. If you want to get more in depth, do a search for using a light dependent resistor and whatnot. But that's it for this video. I will see you in the next video.